Hello students, this is our third lecture of our lecture series for the course Continuous Probability Distribution and Sampling Distribution. So students, today we will learn concept of expectation of random variable. This topic is expectation of random variable and the expectation of a function of a random variable. So this concept is same as of for the discrete part. Just we change the discrete part. We have learned that the expectation of x is equal to summation into x. Thus we make the change that instead of summation we will take the integral. This is the continuous function fx is. So suppose capital X is any continuous random variable. There is seeing the definition of expectation of random variable now. Suppose x is continuous random variable. For this continuous random variable fx is given this PDF. Then the expectation of x is defined as is integration x defined as integration x fx over the range of x. X is defined from minus and infinity. That's it. And provided that this integration, the absolute, this integration is exist. Q of x we have to solve by the help of this definition. Instead of this x, या x ऐवजी जर g of x असं फंक्शन दिलेलं आहे. ही डेफिनेशन आहे एक्सपेक्टेशन ऑफ रॅन्डम व्हेरिएबलची. एक्सपेक्टेशन ऑफ फंक्शन ऑफ रॅन्डम व्हेरिएबल समजा g ऑफ x तुम्हाला दिलेला आहे. e of g of x असं डिफाइन करायचं. e of g of x it is defined as integration simply g of x so one can find out for the continuous random variable e of x square solving e x square. We can solve the expectation of 2x plus 5 integrating 2x plus 5 like this. So you can find out the moments for any random variable by solving the help of the definition of this expectation of random. या ठिकाणी बघा आपण e of x बघितला e of x square बघितला. So with the help of this e of x and e of x square you can compute variance. Know that variance of x is e of x square. In this way we can find out variance. आणि हे जर आपल्याला प्रॉपर डेफिनेशन अप्रोचने बघायचं असेल तसं देखील आपण पाहू शकतो. व्हेरियन्सची डेफिनेशन असते e of x minus e of x square. This is e of x. Suppose e of x is mu. So you can obtain the variance by solving variance हा तुम्हाला या अप्रोचने या फॉर्म्युलाने सुद्धा मिळू शकतो आणि तुम्ही variance हा can obtain this variance by this definition approach. This is the definition of expectation of random variable, the expectation of continuous expectation of function of random variable. This is the discussion of that. With the help of this discussion or with the help of this definition, let's try to solve one example on the basis of this. Suppose one function fx is provided. 0 less than x, 0 other. Question is find mean and variance. Also, it is asked here, mean is nothing but u of x. U of x or variance of x. हे आपल्याला काढायला लावले. Also ask find e of 2x plus 5. Of 2x plus 5. Once we obtain e of x and variance of x, with the help of properties of change of origin and scale, we can find out this second part easily. Now, this is the PDF. This PDF is for the following PDF. This is the PDF. You have to find out the mean and variance. So, e of x, use the definition, integration x fx. This is equals to integration x. X is 6x minus x dx. X is from 0 to 1. So solve this, take 6 outside, multiply this x square inside. This is x square minus x cube. This is from 0 to 1. All this x square integration is x cube by 3 minus x cube integration is x. Limits are from 0 to 6 into, if you plug these values, you will get 1 by 3 minus 1 by 4. 6 into 4 minus 3, 4 minus 3, 1 upon, sorry, 6 upon 12, 1 upon. So we get here u of x value is 1 upon. Similarly, solve e of x square. This is integration x square x is from सॉल्व करूया value put करा like the value of fx it is 6x into x 6 outside multiply this x square into x cube ने मध्ये multiply करा if you multiply this x cube inside you will get x cube minus x raised to 4. This is 6 into x cube integration is x raised to 4 minus x raised to 4 to 5. So if you solve this, what you will get? This 1 by 4 minus 1 by 5 minus 4 is 1 upon x by 2 of x square. The variance of x is equals to x square. E of x square काय आलं या ठिकाणी बघा 6 upon 20 minus e of x square. सॉल्व करूया by 20. But 1 upon 20. So we have computed here for the given PDF of x is equal to 6x into 1 minus x. We get e of x is 1 by 2 and variance of x is 1 by simple. असं इतक्या सोप्या पद्धतीने आपण या ठिकाणी e of x आणि variance of x काढू शकतो. सिम्पली ही डेफिनेशन यूज करायची e of x is integration x into f. e of x square साठी इंटिग्रेशन x square into fx dx यूज करायचा. व्हेरियन्स साठी जो रेग्युलर फॉर्म्युला आहे तो यूज. So this way we can find out the mean and also here it is asked to find out u of 2x plus 5. By the change of origin scale property, it's 2 times u of x plus 5 into u of x ಮೇಲೆ apply 1 by 2. This is 1 plus 5. Similarly, we can obtain variance of 2x plus 5, but simply 4 into variance of x. Variance of x at 1 by 2. 4 into 1 by 20 is 4 by 20 is 1. So this way we can find out the mean and that's it. Now the next concept is moments, raw moments and central. Moments are what? How to define the moments? Moment about any point A is at any arbitrary point, any arbitrary point A. Moments are defined as mu r about A. Notation is mu r about A. They are defined as expectation of x minus A is to. This is the definition. How to solve this for continuous? If this x is continuous, u of x minus a raised to r is integration x minus a raised to r fx. Now there are two types of these moments. One, raw moments. There is what are the raw moments? Raw moments are, these are the moments, they are denoted by mu r dash, and they are the moments about origin, that is 0. If you take a is 0, so you will simply expectation of x. So these are the raw moments. They are defined as u of x raised to r. And if this x is continuous, to solve this you will get integration x raised to r x over x, like this. So mu1 dash is equal to, if you put the different values of r, you will get the different raw. And the next type is central moments. What are the central moments? Central moments, they are denoted by mu r. They are defined as u of x minus mean, because the mean is mu. Integration x minus mu is to r x over x. So this way we have to obtain the central moments. Now there are some relations between these. There are some relations between raw moments and central moments. Raw moments and raw moments and these are very common. We have also seen or we have also learned the earlier classes in the FIBSc. That is, the first is mu1 is always 0. Second one is mu2 is equals to mu2 dash minus 1 dash square. Third one is mu3 is equals to mu3 dash minus 3 times dash mu1 dash plus minus minus 3, this is 1 2 mu1 dash, and the last one is mu4 is equals to mu4 dash minus 4 times mu3 dash 1 dash 1 4 6 2 dash mu1 dash square plus minus this 6 plus 1 7, so minus 4 minus 3 1 dash raised to. These are the relation between raw moments and central moments. This way raw moments and central moments are defined for the continuous random variable. Let's see one example based on this. So this is the PDF. Fx is PDF. And it is asked to find out the raw moments, raw moments, and okay. So how we will find this? As we discussed the definition of raw moments and central moments. So let's compute raw moments first. Mu1 dash is, or you can directly find out the definition of split. Ur dash is equal to expectation of x raised to r. So it is equals to x raised to r na, is integration x raised to r fx dx, integration x raised to x is 1. Solve this, x raised to r, integration of this x raised to r is x raised to r plus 1 on r plus 1. The values of x are from 0 to 1. x ची रेंज काय दिली या ठिकाणी 0 to 1 दिलेली. Take this 1 upon r plus 1 outside. You plug the values x1, 1 raised to something 1, 1. So what we get here, mu r dash is equals to 1 upon. एखादा हे सेपरेट पण सॉल्व्ह करू शकतो. mu1 dash is equal to u of x square काढेल, u of x काढेल, mu2 dash is equal to u of x square काढेल, mu3 dash is u of x cube, mu4 dash is u of x raised to 4. असं वेगळं सॉल्व्ह करेल. तसं न करता एकदाच तुम्ही जर सॉल्व्ह केलं ते जास्त सोपं जातं. नाव पुट युअर व्हॅल्यूज mu1 dash, तर r ची व्हॅल्यू तुम्ही या ठिकाणी 1 टाकली, 2 dash upon 3, mu4 dash, mu3 dash, 4 dash, सेंट्रल मोमेंट्स पण आपण काढून घेऊयात. सेंट्रल मोमेंट हे फॉर्म्युला यूज करून या ठिकाणी काढू शकतो. सेंट्रल मोमेंटचा फॉर्म्युला जर आपण या ठिकाणी बघितलं, that denoted by mu r is expectation of x minus mu. मीन काय मिळालं आपल्याला? मीन इज 1/2. Expectation of x minus mu raised to r x, sorry, not f x, equals to integration minus 1/2 raised to r fx is 1 dx. तर हे तुम्ही सॉल्व्ह केलं तर काय मिळेल बघा, x minus 1/2 raised to r, r plus 1 divided by r plus. x ची व्हॅल्यू आहे 0 to, या ठिकाणी upon r plus 1 outside, simply x minus या ठिकाणी r च्या वेगळ्या व्हॅल्यूज टाका. mu1 मिळेल तुम्हाला r चं x minus 1/2 raised to r plus 1. ठिकाणी mu1 काय यायला पाहिजे, तो 0 यायला पाहिजे. काढायची गरज नाही ना, असं न काढता वन्स यू गेट द रॉ मोमेंट्स, या ठिकाणी हे चुकलं असं मला वाटतं. वन्स यू गेट द रॉ मोमेंट्स यू विल गेट मोमेंट्स ऑल्सो. हो, एकदा तुम्हाला ह्या व्हॅल्यू मिळाल्या, विथ द हेल्प ऑफ रिलेशन्स बिटवीन द रॉ मोमेंट्स अँड सेंटर मोमेंट, 1 is 0, mu2 is mu2 dash minus dash square dash is 1 by 3 minus mu1 dash square is 1 by 4. So 4 minus 3 is 1. Variance is, now mu3 is mu3 dash minus 3 times dash dash 2 times mu3 dash आपल्याला मिळाला आहे 1 by 4 minus 3 times mu2 dash आहे by 3, mu1 dash is 3 मिळालेला आहे, which is 1 plus 2 times mu1 dash is by 2 cube. By 2 cube is 1 upon 8. 1 upon 4 minus this 3 get cancel, 1 upon 2. 2 upon 8 is 1 by 4. 1 by 4 plus 1 by 4, 2 by 4. That is 1 upon 2. 1 upon 2 minus 1 upon 2 is 0. बघा काय आली म्यू3 ची व्हॅल्यू. म्यू3 च्या व्हॅल्यूवरनच आपल्याला इंटरप्रिटेशन देता येतात. डिस्ट्रीब्युशन हे डिस्ट्रीब्युशनचं नेचर काय आहे. If the value of mu3 is 0, therefore we can interpret that the distribution is symmetric in distribution is in. हे तुम्ही गॅमा वन वरनं पण इंटरप्रिट देऊ शकतात. गॅमा वन बीटा वन वरनच ऍक्च्युली द्यायचं असतं आणि त्या फॉर्म्युल्यामध्ये आपल्याला हा म्यू3 लागतो. म्यू3च्या व्हॅल्यूवरनच तुम्हाला इंटरप्रिटेशन देता येतं. एवढं पुढे जायची गरज नाही. So to give the interpretation about the measure of kurtosis, you have to compute the mu4 also. mu4 देखील काढून घेऊया आपण या ठिकाणी. 4 dash minus 4 times mu3 dash mu1 dash six times mu dash dash square 1 minus plus minus 3 times mu dash 2 आणि व्हॅल्यू पुट करा. mu4 dash मिळालेला आहे 1 by 5 minus 4 times mu3 dash is 1 by 4, 1 dash is 1 upon 6 times mu2 dash is 1 upon mu1 dash 1 upon 2, त्याचा स्क्वेअर जर केला तर 1 upon 4 minus 3 times mu1 dash is 1 upon 2 raised to 4 is 1 upon by 5, 4 गेला 4 गेला 1 upon 2 1 upon 2 minus 3 by 16. This get cancelled. Simply 1 upon 5 minus by 16 equals to 16 minus 1 mu4. Now gamma 1 is coefficient of now let's compute coefficient of skewness and kurtosis. Okay, so the coefficient of skewness and kurtosis is gamma 1 coefficient of skewness and it is to under beta 1, where beta 1 is mu3 square upon mu2 cube. व्हॅल्यू या ठिकाणी आपण पुट करूयात. mu3 ची व्हॅल्यू आलेली आहे 0. mu2 ची काही असू द्या, इट इज 0. Since beta 1 is 0, gamma 1 is 0. Therefore, distribution is, already we have interpreted, symmetric in. Now, gamma 2 is equals to beta 2 minus, what is beta 2? Mu 4 upon mu 4 आणि mu 2 ची व्हॅल्यू काय आलेली आहे ठिकाणी बघा. mu 2 is 1/12, 4 is 1/80. mu 2 is 1/12, 1/12 square, 1 upon 144 upon 80. So, which is something greater than 1. 1 point something. Okay. So gamma 2 is, beta 2 is greater than 1. 1 point something. Gamma 2 is 1 minus 1 point something minus 3. It means this is negative. Okay. Less than 0. If gamma 2 is negative, then the interpretation is, if this gamma 2 is equal to 0, distribution is mesogotic. If it is positive, then the leptogotic is interpretation is data is platygotic in nature. That's it. In this way, we have to compute the raw moments and central. So students, in this lecture, what we have learned? We have learned the expectation of random variable, expectation of function of a random variable. Also, we have learned moments, raw moments, and on the basis of this concept, we have to solve some numericals also. The next lecture, we will learn concept of MGF and CGF. For today, that's it. Stop here. Thank you.